Question 5, you're looking at a graph that undergoes a dilation, but also a reflection about the y-axis. So we'll have a graph that will look along the following lines. There's no horizontal asymptote apart from y is equal to 0, so I'll work on that basis. I find the y-intercept, and that occurs when x is equal to 0. Therefore, y is equal to 1/2 times 10 to the 1, which is 5, 0, 5. And I need another point. I'm choosing when x is equal to 1. So 1 is equal to 1/2 times 10 to the 1 minus 1, or y is equal to 1 minus 2, 0.05. I can then go ahead and sketch my graph. Notice how I've automatically generated on my graphics calculator as well. And the range is going to be between 0 and positive infinity. In part B, we've got a graph y is equal to 5 minus 4 times 3 to the minus x. First thing I do is to rewrite that in the format of y is equal to a, lots of b to the power of x, plus k. Straight away, I have a horizontal asymptote at x is equal to 5. That means I peak out at 5. Now, another thing, that minus x means I'm reflected in the x-axis, y-axis, sorry. Now, the negative 4, in turn, inverts that. I'm moving up 5, so I'll have a graph of the following general shape. Y is equal to 5. I'll find my y-intercept as before, and that occurs when x is equal to 0. Or in other words, 1 to 0.01. Now for another point, I'll plug in when x is equal to 1. And that gives me 3 2/3. So you can see there, very much along the lines of my graphics calculator graph. And then sketching this out, it's my horizontal asymptote, 0, 1, and 1, 3 2/3. I could work the x-intercept out as well. I'm not going to in this instance. And you can see my graph hooking up like that. Always pays to have a look at the initial function. A negative x looks like so, power of negative x. A negative of that reflects it. So negative a to the minus x if you wish. And then the elevation to the horizontal asymptote as shown.